It is the giant of the skies, a titan of logistics, capable of moving armies across oceans.
Tanks, helicopters, entire command centers. Nothing is too large for the galaxy.
To understand its scale, one must stand beneath it. A single landing gear strut dwarfs the pilot who commands it. But before it dominates the skies, it begins here, in a factory massive enough to house its birth.
But before it can span the globe, it must be forged. The journey begins here.
It begins as raw potential. Tons of high-strength aerospace aluminum and titanium, destined for the skies.
Computer-controlled mills carve the structural ribs from solid billets. There is no room for error. These frames form the skeleton of the beast. Even bare, the scale is humbling.
Automated systems drive thousands of rivets with mathematical precision, stitching the skin to the frame.
The fuselage takes shape. Its unique double-bubble cross-section is designed to maximize strength and volume.
The cargo floor is reinforced to bear the crushing weight of main battle tanks.
Forward, center, and aft sections are mated. The tube becomes a singular, pressurized vessel.
Empty, the cargo hold is a cavern of aluminum, vast enough to swallow a smaller airliner whole.
The pressure bulkheads are the shield against the thin air of the stratosphere.
Above the cargo hold, a second deck is installed, capable of carrying 73 troops in relative comfort.
Every inch of the skeleton is coated in anti-corrosion primer, a shield against the elements for decades to come. The rear ramp is more than a door. It is a dynamic loading platform engineered to lift heavy armor.
Millions of rivets, each one inspected, each one critical to the structural integrity of the airframe. Before flight, the structure is tortured. Hydraulic rigs simulate the worst turbulence nature can offer. The wing box, the strongest component of the airframe, designed to carry the weight of the world.
Single-piece wing spars span nearly the entire length of the wing, machined from massive extrusions.
Inside the wet wing, workers seal every joint. The wing itself becomes a massive fuel tank. Massive skin panels are lowered into place, forming the aerodynamic surface of the giant. Leading edge slats extend to generate the immense lift needed for heavyweight takeoffs.
Trailing edge flaps, massive enough to serve as wings for smaller planes, are fitted to the rear spars.
The wingmate. A critical operation where the 68-meter span meets the fuselage.
Laser guidance ensures the massive structure aligns with microscopic perfection.
Hydraulic torque wrenches secure bolts the size of artillery shells. The wing is now one with the body.
Reinforced hardpoints await the engines. These joints must transmit nearly 200,000 pounds of thrust.
Miles of stainless steel hydraulic lines are routed through the wing's leading edge, the veins that will power the flight controls.
At the very tip, sensors and navigation lights mark the span of the giant.
The wings are designed to flex, not break. In turbulence, the tips can flex meters without failure.
The upper surface is vast, a literal highway of aluminum for the assembly crew.
Final inspections confirm the marriage of wing and body. The Galaxy now has its wings. The vertical stabilizer, a massive fin rising 20 meters, built to control the giant's yaw. The horizontal stabilizer sits high atop the tail, clear of the turbulent wake from the massive wings. A massive steel pivot allows the entire horizontal tail to move, trimming the aircraft for heavy loads.
Crane operators must lift the tail assembly 6 stories into the air to mate it with the fuselage.
High above the factory floor, the empennage is secured. The Galaxy's silhouette is complete.
The rudder alone had the surface area of a small fighter jet's wing. It commands the direction of the behemoth. Massive hydraulic actuators provide the muscle, driving the control surfaces against the force of the airstream.
From the top of the tail, the view is commanding. Inspectors ensure every bolt at this dizzying height is secure.
Inside the fin, a nervous system of cables runs vertically, connecting the cockpit to the tail.
A full range of motion test confirms the tail is alive. It is ready to guide the giant through the skies.
28 wheels, a landing gear system designed not just to land, but to distribute 400 tons across soft airfields.
The main struts are forged from high-strength steel, born in fire and pressure to survive the hardest landings.
Complex bogie mechanisms are machined to allow the gear to pivot, steer, and even kneel.
A single tire stands nearly as tall as a man. Multiplied by 28, the footprint is enormous.
Carbon brake stacks provide the stopping power, absorbing millions of foot-pounds of energy in seconds. The nose gear is installed. It must support the forward fuselage and steer the giant on the ground.
4 main gear bogies, each with 6 wheels, are mated to the fuselage. A forest of steel and rubber.
Unique to the Galaxy is the kneeling system. Massive screw jacks allow the entire aircraft to lower itself for loading. A maze of hydraulic logic lines controls the sequence. Door open, gear down, lock. In that order, every time.
Massive gear doors are fitted to streamline the fuselage once the wheels are tucked away.
The kneeling system is activated. The giant bows, lowering its cargo deck to truck bed height.
Nitrogen-filled shock absorbers are ready to cushion the impact of a 380-ton touchdown.
Wheel alignment is critical. Drag from a single misaligned bogie could tear the gear apart at landing speeds.
Final lubrication prepares the complex joints for a lifetime of heavy lifting.
The nose visor, a complex compound curve that must be strong enough to withstand bird strikes and supersonic air pressure.
Mounted above the cockpit, Massive hinges allow the entire face of the aircraft to lift towards the sky. Compact hydraulic rams provide the force to lift the multi-ton visor structure in under a minute. In flight, bank vault-style locking mechanisms ensure the nose remains sealed against the slipstream. A continuous weather seal maintains cabin pressure, keeping the crew and cargo safe at 30,000 feet.
The first cycle test. The visor rises, transforming the aerodynamic nose into a gaping maw.
Simultaneously, the forward ramp extends. The bridge is open for business.
Hydraulic flow is calibrated to ensure the multi-ton structure moves with the grace of a feather.
The heart of the beast arrives. 4 high-bypass turbofan engines, each capable of generating massive thrust.
The intake diameter is vast enough for a human to stand inside. It gulps tons of air every second.
Titanium fan blades are inspected for the slightest flaw. At full throttle, the forces here are unimaginable.
Aerodynamic nacelles are crafted to smooth the airflow and contain the roar of the combustion.
Engine number 1 is hoisted to its pylon. A delicate mating dance with 5 tons of machine.
Specialized bolts, costing thousands of dollars each, secure the engine to the wing structure.
Fuel lines and high-pressure bleed air ducts are connected, linking the engines to the aircraft's life support systems.
One by one, the quartet is completed. 4 power plants ready to generate nearly 200,000 pounds of thrust. The spinner cone is attached. Its spiral pattern will soon blur into a warning for ground crews. Digital engine controls are linked. The brain of the aircraft can now talk to the muscle.
A final foreign object damage check ensures the intake is pristine. Even a loose bolt here would be catastrophic.
4 engines, mounted and ready. The Galaxy now has the power to lift mountains. Before the first fuel is burned, simulations verify the airflow and thrust calculations. The flight deck, an office in the sky for a crew of 6, commanding the largest aircraft in the inventory. The main instrument panel is installed, a wall of information vital for global navigation.
Modern avionics replace steam gauges. Glass cockpit displays bring the Galaxy into the digital age.
The heavy control yokes and throttle quadrant are the direct link between the pilot's hands and the machine's power.
Miles of wiring lie beneath the floorboards, the nervous system that carries commands to every corner of the airframe.
Thousands of circuit breakers protect the electrical systems. The flight engineer's panel is a wall of redundancy. In the avionics bay, the flight computers are installed, the digital brains that interpret the pilot's will.
The radar dome has been installed, housing the weather radar that allows the giant to see through the storms.
This system is the only thing keeping the crew alive.
For missions spanning the globe, crew rest areas are installed. This plane is a home for days at a time. Preparation is key. Crews spend days masking delicate sensors and glass before a single drop of paint is sprayed. Gallons of specialized radar-absorbent gray paint are applied. The patchwork skin becomes a uniform armor. The identity is revealed. The letters U.S. Air Force mark it as property of the most powerful air arm in history. A tail number is assigned. This unique code will stay with the aircraft for its entire service life. Emerging from the paint barn, the Galaxy is no longer a collection of parts. It is a warship of the sky. Before flight, it must be weighed. Every pound of structure is accounted for to ensure stable flight. It drinks deep. The wings can hold enough fuel to drive a standard car around the world dozens of times.
The machine is ready. Now, the human element takes command. Pilots, engineers, and loadmasters.
The walk-around. A final ritual inspection where the pilot meets the plane face to face.
Turning 3. High-pressure air spins the massive fans. Fuel is introduced. Ignition. All 4 engines stabilize. The air behind the Galaxy boils with thermal energy. Releasing the brakes, nearly 400 tons of metal and fuel begins to roll towards the runway.
Throttles forward. Takeoff power is set.
Rotate. 200,000 pounds.
80 knots! 100 knots! The momentum is unstoppable.
Gear up. The massive bogies rotate and fold away, cleaning up the lines for crews. A slow, deliberate turn. The Galaxy does not dart. It sweeps across the sky. From the cockpit, the pilots watch the nose of their own aircraft disappear upwards. Punching through the cloud deck, it enters its domain, the stratosphere.
At 30,000 feet, the Galaxy settles into its stride. Crossing oceans is just a day's work.
Ride securely. Tanks, helicopters, supplies, waiting to be delivered to the front lines. Destination in sight. The giant dirties up, extending flaps and gear to slow its massive bulk.
Over the threshold, the pilot flares, trading speed for a gentle touchdown.
Contact. 28 tires scream as they take the load. Thrust reversers open. The engines roar one last time, fighting the momentum to bring the beast to a halt.
Mission complete. The C-5 Galaxy. A monument to American engineering and global reach.
75 meters long. Its fuselage stretches nearly the entire length of an American football field.